Greetings, hello, hey, welcome to the last example of application and of Norton Theorem. So this is our last example. Question is given and you asked to find the load current across the 7 ohm resistor using Norton Theorem. So as usual, you'll go ahead and isolate, cut your load resistor out of the circuit, and you'll be left with an open circuit. This portion will be open. So this is our point of interest. From this point, you would evaluate your equivalent resistance, or you combine all these resistors. All these resistors you combine into a single resistor called Rn. But before doing that, before you go to combining resistance, take this guy, take the load resistor and attach it to the Norton equivalent circuit. Okay, then check what you don't have and find that we have the load resistor, we do not have Norton resistance, and we also do not have Norton current. So we need to find those. How do we do that? Well, we'll show you just now. If you want to find the Norton resistance, it's the same approach as you would for your Thevenin resistance. And heads up, your Norton resistance is actually the same as your Thevenin resistance. So if you have a current source, what do you do? As we had here, well, you open the circuit, you remove the current source, as we just did right here. We remove the current source, open the circuit, and we'll be getting our R Norton from there, measuring using a multimeter to find out what is the total resistance of all these guys. So to do that, these two and these two right away, they are in series, so you can add them. You can say R equivalent 1 is equals to 36 plus 8, that's 44 ohms. 44 ohms, that is in parallel with the 4 ohm resistor. So R equivalent to 1 over 44 plus 1 over 4. That gives me 3.667 ohms. 3.667 ohms. Just make sure 1 over 44 plus 1 over 4, 3.667. Alright. So with that done, then we can redraw this circuit now. Redraw the new circuit. It will look like this. It will have a single resistor connected to the 6 in series with the 6 ohm resistor. Okay. Therefore, R Norton is equal to 3.667 plus. The whole idea is we want to combine all of these into a single resistor, and that single resistor of all the combined resistor is our R Norton or our R Thevenin. (9.667 ohms). So we have R Norton 9.667 ohms. So we have this now 9.667 ohms. So we have the two resistors. Now we're only left with I Norton. So let's find I Norton, shall we? To find I Norton, let's bring back all the sources. Current sources, voltage sources, whatever they may be, we bring them back. In this case, we only had a current source, so we only bring back the current source. Can't bring back something that was not there. Bring back the current source, and we short circuit the point which we had opened, the terminals that were open. And from that short circuit point, that's where we can measure our short circuit current, which is the same as our Norton current. Right from here, you can see that 6 and 4 are parallel to one another, and they're in series with that resistor. So I can combine those ones, get my equivalent resistor of 1/4 plus 1/6 plus 8, equivalent resistor of 1/6 plus 1/4, that's 2.4 plus 8, 2.4 plus 8, that gives me 10.4 ohms. So we have 10.4 ohms. Okay, so we have this, which is the combination of all this. So I can replace all that with a single resistor that is in parallel with 36, the 36 resistor. Okay, so we'll have our current source connected to our 36, connected to our equivalent resistor. This is 10.4 ohms, and this is 36, and we have 65 amps. 65 amps supplies current that will flow from the 65 amp source, my source, and all the way to this junction, and upon reaching this junction it will divide I1. Let's call that I1 and call this one I2, and our point of interest here is I2. So I2, using current divider, we're able to say 65 times the resistor that we're not interested plus the total sum of the resistors, 10.4. Okay, 65 times 36 divided by 10.4 plus 36 gives us 50.43. 50.43 amps as my I2. So current flowing across the 10.4 resistor is 40.43. What else do we know about the 10 ohm resistor? A 10.4 ohm resistor. Well, that current that passes through the current passing through this resistor, which is called I2, through the 8 ohm resistor, will be the same current leaving the 8 ohm resistor. As it arrives at, let's call this one junction 2. Junction 2, you will observe that it divides again. There's current division here. So we need to do current division twice here. So I2 becomes our source current here, and let's call this current passing through the 6 ohm resistor our short circuit current, which is the current of our interest. So let me just correct this. I short circuit, which is IN, is equal to I2 multiplied by 4 divided by 4 plus 6. So what is I2? I2 is 50.43 multiplied by 4 divided by 4 plus 6 times 4 divided by 4 plus 6. 20.17 amps is our short circuit current. So that's our IN, our I Norton 20.17. Then with that info, we can complete our circuit. I Norton is 20.17 amps. So IL is equals to 20.17 amps multiplied by, we're interested in IL, so multiplied by the resistor, but we're not the resistance that we are not interested in, 9.667 divided by, well, yeah, we divide by the total of the two resistors. 9.667 plus 7. So times 9.667, 9.667 plus 7, which gives me 11.70 amps, which is our load current. Thank you for watching, and I wish you well with the exam. God bless you.